About 4 minutes left at this point. Two more minutes. One minute left. Good. 30 seconds left. make sure you finish up, just get something written down, and then we'll go over it. Okay, that's time. Seemed like I gave you all an extra 3 minutes on it. Seemed like people were a little bit pressed for time there. Yeah, these list things can get complicated, and yeah. Well, let's go ahead and go over them. So the first problem, really just testing your. So again, the difference between the sequential for loops and the nested for loops. And so we do this first for loop by itself, and then we do this second for loop all by itself. There's no interaction between the two of them. I'm just gonna skip over here to the end. And so the total is 6. The difference between this one and the last ones, or the practice quiz, is the ranges are different, and both of these have plus equal to I. Number 1, the answer is 6. Number 2, here we have the nested for loop instead of the sequential for loop. And so this inner one repeats once for every time this outer one goes. And now press last, skip over to the last one, and we get the total equals 9 for number 2. And again, we're going over these answers. You're grading your own quiz in class so that you can have a chance to review this material as we're going over it and seeing whatever mistakes you made. If you do have questions about any of the problems as we go over them, feel free to stop me and ask about that. Okay, number 3, another one that is nested for loops. The difference between this one and the previous one is there's 2 differences. The main difference is that this range right here is over I instead of over 3, but then our total is also plus equal to I. And so when I'm stepping through this one, now this range right here, this I is going to start off at 0 the very first time, so I'm not even going to do anything because range of 0 has nothing to go inside of. And the second time, range is 1, so it's only 0 that we go inside of, and there I equals 1, so total will plus equal 1. And then the third time, when I equals 2, for j in range 2, that'll be 0 and 1. And now it's important that this total plus equals I, it's the I value right here and not the j value that I'm going to be adding. So I'm going to be adding 2 each time. So press next, you see that I added 2 because it's plus equal to I, not plus equals j. So total's 2. Do it one more time. And we got total 5. Now we've ended the j for loop and ended the I for loop. Print out the result of total equals 5. So a lot of sort of subtle things to pay attention to here with just what letter is it? Is it nested? Is it sequential? And depending on all those things, our answers are going to be slightly different, and but important things to pay attention to here. And as you get more experience reading these short snippets of code and writing them, your eyes will just zoom in to all these things and notice these like subtle differences really quick. So number 4, another nested for loop. The sort of trick on this one is that the step size over here is I on the inner loop. So we'll walk through this. The I starts at 1 because the range up here starts from 1. And now down here, my step size is 1. I right here is 1. So this range from 0 to 4, step of 1 is going to be 0, 1, 2, 3. And so total plus equals j each time. So j equals 1, add that to total. J equals 2, add that to total. Total will be equal to 3. J equals 3, add that to total. Total will be equal to 6. We've done 0, 1, 2, 3 for the range up here. So now we're done with this range, done with this for loop. Go back up to the I for loop. And our next I value is 2. Range from 1 to 3 gives us 1 and 2. So 2 will be the last one. Down here, now we have 0, 4, and 2. So we're going to step up by 2 each time instead of by 1 each time. And so we'll start again with j equals 0. Total plus equals j. Not going to change anything. But now here's the key thing, that I is going to be equal to 2 instead of equal to 1. And now total plus equals j. It's 2 right there. And then the next time through, it would be 4, but we don't include the last one. So we're all done with that loop, all done with that loop. Print out total equals 8 for number 4. Number 5. So here we're starting to go into the lists instead of the nested loops. And this one's just practicing your indexing onto lists. Again, this square bracket operator can be called the square bracket operator, the indexing operator, the subscripting operator, the at operator. All those things are just synonyms of each other. I'll use all of those things in class interchangeably. And yeah, press the last, it evaluates all of this. The indexes that it's looking at are 2, 3, and 4. So you have to just remember that you count from 0 instead of 1, and you add up those numbers, and you get 12. Okay, 12. Number 6. So here, the shorter list, the key thing on this one is that when you have 4x in XS, it's not looking at the indexes. That when you're doing a range, you're getting indexes. When you have a list to the right, you're just getting the actual entries, the values, the items in the list. And so here, when we do total plus equals x, it's going to be the 1, the 3, and the 5, and not a 0, 1, and 2. So 1 plus 3 plus 5 gives you 9 for the total. That's number 6, 9. Number 7. So here, the difference now is we're using the range again to get indexes into this list rather than just the values from the list. And this pattern of range of length of a list is a very common pattern in Python. You'll see it a lot when you need to access the indexes instead of the values. And so this XS at I gives us the actual value at that position, and then we're just taking the value times the index here. We'll step through this. The very first time through, I equals 0, so XS at I is 1, but we're multiplying it by 0, so total just gets 0 added to it. The next time through, I equals 1, XS at I is 3 here, so 3 times 1 is 3. We'll add 3 to total, and there's 3 added to total. Now the last time through, we're looking at the last index, position 2 right here. XS at I is 5 in position 2, so 5 times 2 is 10. Total plus 10 will give us 13, and that's the end of the for loop, and so we print out 13. That's the answer for number 7. All right. Yes.
I'm sorry, I just have a quick question.
Sure.
Since it's len XS, the range is, so it's for I in range of 3, so you go 0, 1, 2.
Exactly. Yep. Yeah, good question. The question is, with this pattern of range, length, XS, the length here of this list is 3. And when we do the range, we don't include the last thing, but we do start at 0, so 0, 1, and 2. And those are the indexes into this list. It does seem weird. It takes a lot of getting used to this idea of like lists starting at 0, and but the reason lists start at 0 and sort of the reason on the range, the end position, we don't include the end position is so that patterns like this just kind of work out like we want them to. Like if we want to get every index in a list, there's this nice pattern that'll give that to us. And in order for it to have this nice pattern in this situation and other situations, we have to count our indexing starting at 0, and our ranges, we have to make them not include the endpoint. So it's those sort of interaction between those things that gives us, is why we have that sort of weird behavior in computer science. But ultimately, it lets us do these patterns like this that make things simpler. Good question. Again, I'll definitely feel free to stop as you have questions about any of these problems. So this one, number 8, we have 2 lists, XS and YS, and we're looping through them both. This problem is very similar to the one on the practice quiz, except I just changed the order of doing the for loops. So we do the Y list first, and then the X list on the inside. So stepping through here. So we're at the for loop. Here's our Y list and our X list over here. Again, the thing down here, these are the values of the list. These up here are the indexes into the list. And when we do the for Y and YS, that's giving us these values. So that's going to be the 2, 4, and 6. Doesn't care at all about the indexes up here. So the very first time is 2. Total plus equals Y is equal to 2. We can see that down here, right here. So total plus equals 2. And now for X and XS, X is going to be all of these 3 things right here, 1, 3, and 5. And we're going to subtract those multiplied by Y. So first time just totally undoes what we did up here. Next time, X times Y, X equals 3, Y equals 2. So that's 6, negative 6 is what total is going to be. One more time. X is 5, Y is 2, that's 10, so minus 10, negative 16. Come back up to the Y loop up here, total plus equals Y, the next Y is 3. So, the next Y is 4, right here, not the 3 for the X, it's the 4 right here. So when we change total, it was previously 16, and then negative 16 plus 4 is negative 12. Going through this X loop again, 1, 3, 5 times 4, subtracting. So the first time, negative 4 undoes what we did up here. Back to negative 16. Now we have Y times X is 12, negative 16 minus 12, minus 28. One more time, 4 times 5 is 20, minus 28, minus 20, minus 48. And back up here. Last time through, total plus equals Y, so 6. Negative 48 plus 6, negative 42. And just keep doing that same pattern, and you get to negative 96. So this one had a lot of things going on inside of it, but maybe the hardest part was that there's relatively big numbers of like 4 and 6 and 5 that needed to get multiplied together and added together, and maybe easy to make a arithmetic mistake there.
Yeah, let's say we did 6 times 3 is 16 and not 18.
So yeah, if you had just an arithmetic mistake, then you don't get the points. Sorry about that, but you should also not feel bad. Like, you got the main thing of the problem. But also when you're looking at code and debugging code and trying to figure it out, there's going to be a lot of times, there's been a lot of times in my life where I've spent hours and hours looking at a piece of code that was only tricky because I was doing a stupid arithmetic mistake in my head. And so these problems are designed to train you to help know what those stupid arithmetic mistakes should be, should not be, find those things, focus on them so that you are not going to get tripped up on them. Again, so the particular points you get on these quizzes, not going to be hugely impacting of your grade if you miss 1 or 2 questions. We're going to, a little bit later today, talk about your first homework assignments, and there'll be lots of extra credit in there that you can use to make up for any missed quiz points. But the real thing about these quizzes and all these problems that I've selected for the quizzes is that if you can do these quizzes, then when you go to the actual problems and are trying to debug things, you're going to be able to work through them in your head well and not spend just like hours banging your head against the keyboard because of avoidable mistakes. So, long answer to the question of, do you get penalized for arithmetic mistakes? But yes, you do, and that's the pedagogical reason for it. Number 9. So this is where we start with the nested lists, and I guess the key tricky thing in this one is that I was indexing by -1 right here. So if we go ahead and step through this, create those lists. Now for XS and XSS, so that's going to be, and this one right here is the XSS. These 3 lists are what's going to take on the value of XS. This one is the first one right here because that one is at position 0 in the XSS list. So XS now pointing over to this list right here. Total plus equals XS at -1. Here's XS, here's the -1 position, so we get 6, total plus equals 6. And now for X in XS, the same list right here, subtract off the X's. So first subtract 2, then subtract 4, then subtract 6. Minus equals 2, minus equals 4, minus equals 6. And so we get total is -6 after the first loop through here. Redo that for each one of these other lists. And so after the first one, there we go, -7 after the first time around, and let's jump to the very end, you get -10. And the last one. So another nested list problem. Here, the tricky thing is that this condition here is just, there's a lot going on right here. So let's step through till we get to that spot. Each of these two for loops, they're not going over the values at all, they're going over the indexes. So this I is an index into the XSS list, so it'll be the 0, 1, and the 2 right here. And then this J is an index into the corresponding lists down here. And the first time that we go through it, it'll be this list right here. J will be 0, 1, and 2. The second time, it'll be this list right here, 0, 1. And then the last time, it'll be 0, 1, 2, 3, 4. When we're actually doing this computation right here, though, we have to, so here, XSS at -1 minus 1, well, that's going to be the very last so negative I minus 1, I is 0, -0 minus 1 is -1. So this points actually this right here to this list right here. Then the -J also starting at 0, so gives us that 0 position, gives us the value of 0, and this whole thing right here becomes 0, adding 0 to total, and so total stays the same. Stepping through again. Now, the next time, I is still going to be equal to 0, so this 0 minus 1 is still equal to 0. Now this J over here is going to be equal to 1, because that's the next thing in this range right here. So we're getting this 1 value right here, adding that 1 into total. Oops. Sorry, and then the J is negative, so it's the -1, so it's this position right here. -1 gives us that right there. And then the next time, -2 will give us that right there. 2 into total gives us 5. And yeah, so just lots of tricky keeping track of exactly what this is pointing to each time. Jumping up ahead all the way, you get 23 as the final answer. So lots of, this last problem definitely had lots of just tricky things to think about here, easy to make mistakes on what this is actually referring to. And yeah, anytime you think there might be a negative in these lists, always pay extra attention to that. Make sure you have your total added up together on the front of the quiz. And since it is 2 pages, put your name on both of the pages and pass both of the pages up front. Any other? Yes. Any other quizzes? Do I have them all? Okay. So today, what we're going to talk about, I've posted your next homework assignment, and we'll be going over that in class today. The homework is about working with text data, and so that's our sort of theme for this week. There's inside of the textbook, chapter 6 is what all the textbook material that we'll be covering. There's these videos down here which cover material that is not in the textbook. This material is not something that you will be required to use on the assignment, but some of the techniques in these videos down here do make some of the homework and lab functions much easier to implement. So if you're I'm labeling these as intermediate level videos. If you're looking for new techniques that maybe make the homework easier, then watch these. If you just want to stick with the techniques that we cover in class, then these are not required to watch. A video that you do want to watch by next Wednesday is this one down here on something called non-decimal number systems under references here. This is, so it talks about like binary, something called octal and hexadecimal. And on Wednesday, I'm going to be assuming that you have basic familiarity with these non-decimal number systems. Because it's important to understand those in order to understand how text is actually represented physically in the computer. And that's what we'll be talking about on Wednesday. Specifically something called Unicode, which is sort of an international system for representing both English and non-English text inside of computers. So starting on Wednesday, we'll be talking about if you have like Korean text or Spanish or Chinese or Arabic, how does that all get represented in a computer? But before we, dive into any of that, let's talk about our homework assignments. And so I have on the class webpage, there's a homework 1 folder that has the actual homework assignments inside of it. What this homework assignment is it's a Markdown to HTML compiler. And so we'll talk about, we have talked about HTML, and today we'll talk about this new language called Markdown and what a compiler is. Basically, a compiler is something that converts from one programming language into another programming language. And so we're going to convert from this Markdown programming language into this HTML programming language. And so in order to do that, the first thing we need to do is understand what Markdown actually is. And if we scroll down here, I have a little paragraph right here explaining why Markdown is important and why you should care about it. So the first thing is that it's a so remember that in HTML, the M here stands for markup. This is hypertext markup language. And so computer scientists, being the clever people that we are, decided that something that is down is simpler than something that is up. And so we call this Markdown as like the simplest possible markup language. And it's widely used in lots of different places. So lots of social media websites use it, like Reddit, or if you take the CS36 course, the fundamentals of data science, all of your homework assignments get implemented in something called R Markdown. And my own personal blog is actually written in Markdown and then automatically converted into HTML. The vast majority of blogs that programmers use, they don't write HTML directly, they write Markdown. If you've ever used WordPress or any of those like popular blogging platforms, those all natively support Markdown. And then the last place is that GitHub uses Markdown as well. This link right here, this GitHub flavored Markdown, this is what you should use as your reference on like what are the basic commands inside of Markdown. So we'll go over some of them right now, but if ever you have like a question, this is the thing that you should reference, and this is the thing that we're going to be implementing in your homework assignments. Any questions so far before we like talk about the details of Markdown? Was that a? What are the details of?
What would Markdown be closest related to?
Okay. So the thing that Markdown is most closely related to is HTML. It's an alternative to HTML. So inside of the issues, I've posted a new issue called the lab post, and this will be something that you'll have to do on the lab this week. Basically, the lab's going to ask you to create your own some Markdown just as practice of generating Markdown. And this has some basic instructions here on how to do it. And what I'm going to do is I'm just going to skip down here to this comment right here and say, this is a comment I'm creating in section 1 today. And if I press this preview button right here, you can see that the preview button has no special formatting at all on what's getting displayed. What Markdown does is it lets us provide that formatting. So this is a comment I'm creating in section 1 today. This is bold. So if you have two stars on each side of something, then the thing inside of that is going to become bold. And so we know how to make bold happen in HTML. We can use that B tag or that strong tag to make bold happen. And so inside of GitHub here, when I press on this preview link, what they're doing is they're compiling this Markdown right here into HTML. They're converting these stars right here into the bold tag, basically changing that into, say that GitHub converts that into that for us automatically. And at first, I mean, this isn't like too big of a deal because this and this are basically just as readable as each other. They both generate the same result over here, and like this and this are kind of just as readable as each other. But one thing that's nice about Markdown is that I don't have to add p tags automatically. So this is a new paragraph. And if I come over here to the preview, you can see that we have one paragraph here and one paragraph here. But in HTML, if white space doesn't matter in HTML, you have to explicitly include those p tags. In Markdown, you don't have to explicitly include any p tags to generate a new paragraph. There's a lot of these different commands that you can use. Again, I have this link right here to the GitHub guide to Markdown, but you can make things bold and italic, strike through, add links, add little code blocks like this. Let's go ahead and talk about the syntax for adding a link, since that's another important one. For HTML, if we wanted to add a link, we have to do something like href equals, I'll make a link to github.com/mikeisvicky/cmc-csci040. This is the course web page, like that. And if I know HTML, then this is like, okay, that's readable. But the Markdown syntax is going to be even more readable than this. In Markdown, we put inside of square brackets here the text that we want to display, like this. And then inside of parentheses, we put the URL that we want to link to, like that. And now if I click on preview, so it's not actually displaying the HTML, it's not rendering the HTML up here, but this is the equivalent thing down here.
So square brackets.
Yeah, so if you're making a link, it's square brackets and encloses the text that's going to be the thing that gets displayed, and then parentheses encloses the URL that you're going to link to. The most important takeaway at this point, though, is just that Markdown is somehow a simpler thing than HTML. It's closely related. You can do the same things as HTML, but it's somehow simpler. For completing this portion of the lab, you're going to actually have to click here, reference the instructions to see how do you do all of these different formatting things, and whoops. And so you don't need to try to like have memorized at this point all these different things. But again, the advantage is that once you know Markdown, you can leave these get this formatting in lots and lots of different places in your life. You can do it here in GitHub comments. You can do it in Reddit if you use that. There's lots of other social media sites that support Markdown. Personal blogs, R, when you take your other classes, lots of different places. So the takeaway is that this does have lots of applications. Any questions about just what Markdown is at this point? Any?
It's the MD file, right?
The question is, what if you're creating a Markdown file? How do you name the file? And the answer is that a Markdown file ends in .md. So actually, all of the things that we've seen in class, all of the like this document right here, our syllabus, this is actually just a Markdown file, and it's being converted, compiled into HTML. This readme.md right here is the sort of the source code of this Markdown file that generates all of this stuff down here. Good question. Any other questions so far? Okay, let's head back to our assignment. And so that's just the quick description of what we're doing. We're converting this Markdown into HTML. We'll see here in a second what the code looks like to do that. I'm giving you quite a bit of starter code for this. But first, I just want to talk about a sort of financial aside, another sort of application about this. And so we've seen just now that GitHub has an implementation that converts Markdown into HTML. And I want to think about how much did it cost GitHub to do this? Well, if I were working at GitHub, then I would assign this task to an entry-level engineer, so somebody straight out of college, and expect them to complete it in about 1 week. Entry-level engineers at GitHub make about $150,000 a year, so that's about $3,000 a week after you take into account vacation and holidays. This number right here, again, I'm taking it from this levels.fyi website. So their E1 rank, somebody straight out of college right here. This is probably like 2 or 3 years of experience, and then maybe 10+ years of experience down here. And so GitHub paid somebody about $3,000 to implement this conversion from HTML to Markdown, which is basically what your homework assignment is. So somebody has been paid in the past $3,000 to do what you're doing for this homework. And so another question is, like, was this a good investment for GitHub? And so GitHub currently has about 90 million active users. And if you work out the math, that works out to they spent about 0.005 cents per user on this feature. And this is only a one-time thing, but these users are going to continue using GitHub sort of forever, or until GitHub goes away. And so on average, GitHub makes about $4 per user per month. and most of this is based on GitHub sells people computing time, which is something that we're not using in this class, but most people, say at a company, are using a lot more than $4 per month in compute time, so it averages out to about this. And so this discrepancy in that, like, one person implemented something that's used by millions of people and is enabling, along with many other things, but is enabling quite a lot of revenue to come in, is why programmers can make so much money. If you're interested in like sort of spitballing these figures, maybe going into project management and like estimating timelines for projects, there's a whole field of study about that called software engineering. And both MUD and Pomona have courses in software engineering about how you can do this kind of thing. Guess about how long it should take for somebody at different levels to complete a project and how much money it's going to cost. Yeah, so that's just a fun aside about the assignments. I don't know, does anybody have questions about that? Okay, due date. So something close to everybody's heart here. So originally, I had it scheduled that it would be this coming Sunday at midnight. But let's go ahead and give you 2 weeks to work on it instead of just 1 week. This is a harder assignment, so that's one reason I'm giving you 2 weeks to complete the assignment. This is also, I think, probably about the time when midterms are maybe happening in other classes, and so I don't want you to necessarily, depending on whether this week is like the busy week for you or next week is the busy week, you should schedule around that when you're going to work on this assignment. So you have 2 weeks to complete it, but really today and Wednesday, we'll talk about everything you need to complete the assignment. And then last big picture thing, what should you be taking away learning-wise from this assignment? So the first thing is how to use this Markdown language, all the different features of it. Again, very commonly used in all throughout computer science. Then string manipulation in Python, that's our new sort of concepts that we're covering this week. And then this idea of a compiler, that a compiler can convert from one language into another language. And so even if it seems like one language is maybe limited, if you can convert from one language into another language, then it means you can get all the features of those other languages just by converting between the two. And this is something that we're going to be using throughout this course of, by the end of the course, you'll be creating a sort of a clone of Twitter. And in order to do so, we'll be working in multiple different programming languages where some languages get converted into other languages, and maybe even through multiple steps in a pipeline of it starts in one language and gets converted multiple times by the time it's in HTML and can be seen by the user. Any questions about any of that, big picture things on the project? Okay, so on this project, there's this markdown compiler.py file, and that's where all the code that you're going to have to work with is located. And so let's go and take a look inside that file. I have that opened up on VS Code right over here. And if you look at this file, there's a lot of stuff inside this file. So I'm providing you 500 and some odd lines of starter code in this file. And most of this file, it contains functions sort of like you've worked on in lab. Like, so at the very beginning, there's this compile headers function, and it takes as input this markdown specific to what's called a header in Markdown. The hashtag makes a header, and it converts it into this h1 tag. And it has doc tests just to make sure that this feature of Markdown works. And then if we go down to the next one, there's compile italic star. So if you have just a single star around a piece of text, it makes that text italic. And so each one of these functions is just going to be working on an individual part of Markdown, one of these individual commands. And you should start this assignment by just focusing on, like, pick one of these functions and make sure that the doc tests pass. And once you get the doc tests passing for all these functions, then everything will just sort of magically come together as a program that can convert any Markdown document into an HTML document. Question, yes?
Where is Markdown compiler?
Question is, where is the Markdown compiler.py file? It's in the class repo / homework1. And that's also where this instructions file is located. So that's the first section of this code. And again, that's where you want to start. That all of this follows the same format that we've been doing in lab. This next section of code down here has a little bit more complicated functions. And in particular, I'm providing you code down here that sort of automatically calls these other functions for you and does stuff with them. So at the beginning, you don't have to look inside of this code at all. You just start by making the compile headers function work. And you know it works because it passes the doc tests. And once it does, then this function down here, since it uses compiles headers inside of it, it's now going to have that feature added to it. And then there's a couple of functions down in here that I'm providing you starter code for. And at this point, we won't talk about, you don't have to think about modifying them. There's a few slight modifications that you will have to do, but we'll talk about that a little bit later. At the beginning, it's just focus on these doc tests up here. This last part of the code down here, this final section, is something that you don't have to modify at all, but we're going to talk about right now exactly what it's doing. What it does is it links this terminal command, terminal down here, to the different functions that we have up above. And in order to illustrate how this works, what I'm going to do is I'm going to press the triangle button right now on this code. And if I press the triangle button, you'll see that at the very beginning, I'm getting an error message down here. And what this error message is saying is that it doesn't know what file it should be working on to convert from Markdown to HTML. And so in order to use this code, I have to tell it what file to use. And down here is the syntax that it wants me to use. When it says usage like this, that means this is how you actually call this file. If we come back over to the instructions and scroll down into here under this instructions part, it also has this information down here. It says at the very beginning, work on just making sure that the doc tests pass, just like in the labs that we worked on. But then down here, these are the commands that you'll use that you'll run to actually use your Markdown to HTML compiler. And so before, we would do just like Python 3 and then the name of the file. But now we're going to add this -- input equals, and then whatever the name of the file is that we want to process. In this case, we're processing the readme.md file, which is this file that we're looking at right here. It's the readme.md is the file that GitHub displays. And here, GitHub has converted it into HTML. But if we were to just look at the readme.md file itself, press raw to look at what it is, you can see that it's not HTML code. It's this Markdown code that has this sort of weird sort of syntax. And we have to convert this into HTML in order to be able to display it nicely inside of Firefox. So these commands at the bottom right here show how to do that. I'm going to go ahead and do that inside of here, inside of this, inside of VS Code now. And yeah.
Which command do you copy and paste?
So I haven't copied and pasted anything.
Oh.
So in order to run this, what I'm going to do is you first press the triangle button. The triangle button gives you the command for how to run this Python file specific to your particular computer. So it starts with the Python 3 and then a big long file name for where your Markdown compiler.py file is located. Then it's going to have this usage thing down here, which gives you the instructions on what you need to do. And it's saying down here that you need to add this -- input file and then the name of input file. So I'll press the up arrow to go back to my previous command, space -- input _ file. And you can see that on my computer, based on my screen size, this is running over to the next line down here, that this file, they're should be an E at the end of here, and there actually is because it's down here on the bottom left. And so depending on how big your screen size is, this may or may not happen to you. So input file, then space, I want to do it on the readme.md file. And I'm not going to hit enter yet. Instead, let's look up here in this list of files that I have in this folder that I currently have open. I currently have open my homework 1 folder, and you can see there's this readme.md file here. I'll click on this. This is the same, again, readme.md file that we saw on GitHub. Again, not an HTML file. But down here, as soon as I press enter, and now I don't have an error message down here. No error message because I added this -- input file readme right here, and that's what it was asking for up here, so no error message. Up here, you'll see now this readme.html, it did not used to exist, but now it does exist. And if I click on it, it now has all of this HTML right here that I can now open up and load in Firefox.
So to run this, we should copy and paste the raw readme file from GitHub and then create a new file on VS Code that's just that.
To run this, you'll need to download all of the files inside of the homework 1 folder into a folder on your computer, and then open up that folder inside of VS Code, and then you'll have both the Markdown compiler and the README, and you'll need the image in order to make it all work together. So you need everything that's in the homework 1 folder on your computer.
Where do we download?
We'll get to that. Yeah, good question. The question is, how do I download all those things? And we're not ready to talk about that yet. So here, again, the readme.html, this is the HTML file that I can now load into Firefox. I'm going to go ahead and do that just so that we can see what the output looks like. And so right here, I have opened up the folder that is where my all my files are located. You can see that previously there was no readme.html, only this readme.md. If I refresh this folder, because I've run that command now, this readme.html exists, and I can click on it, and here is the output of running that. At the beginning of this assignment, you haven't implemented any of the functions that convert from Markdown to HTML yet. And so when you first run this program, if you haven't implemented anything, it's going to kind of look like gibberish. It's going to look like exactly what the Markdown file looks like. It'll still have this hashtag at the beginning. It'll have this thing here. This is how you load an image in Markdown. We saw the ** before is how you make something bold. And as you implement each one of these functions, this page will slowly get nicer and nicer looking until it starts looking like a real HTML file. To give you a sense about what the final output is going to look like, I'm just going to run this on the using the answer key. So here's compiler _key, hit enter. This ran it with my answer key instead of the original source code. And now if I refresh this, now you can see there's an actual H1 up here. There's an actual image loaded here. This description is in bold, that financial aside. Here's some strikeouts, and so things look a lot nicer. So there's sort of 2 ways that you can measure your progress on this assignment. There's the, I guess the traditional, the classic, the lab way of just looking at the actual, the doc tests and making sure that you're passing the individual doc tests. But then you can also just actually run your command down here, look at the web page, and see that it's slowly getting nicer and nicer as you're adding all these features to it. Any questions about that so far? Okay, so there's 2 commands actually that you'll want to run on this assignment while you're converting things. This one right here and this one right here. And what I'm asking you to do as part of this assignment is to take screenshots of Firefox loading the web page after having run both of these commands. The difference between these two commands, just from like a literal perspective, is that this one has this extra piece of information down here, this -- add CSS. And what this does is it chooses to render the HTML in a different way by including a different CSS file in our output. In order to see what that looks like, I'm going to come down here again, press the up arrow, and then actually add that command, the -- add _ CSS right here, and hit enter. And now when I come over to Firefox and load up this web page, I'm going to press refresh right here to load the new web page that was just created with the add CSS flag. And now you can see that things are a little bit different, that everything's centered. There's a maximum width to the text. If we look down, there's some code blocks down here that are actually like kind of called out a little bit nicer from the text. There's these horizontal lines appearing between different sections. And this is all the CSS that got added with that -- add CSS flag is doing this for us. And this illustrates another like major advantage of using Markdown over just raw HTML in order to do things. And that's that depending on where I want to display this file, I might want to have things formatted slightly differently. Like if I'm putting it on a web page, then I might want it to, I probably will want to have it nicely formatted for a web page. But if I'm going to print it out, I might want things to be slightly different so that it looks nicer on print. And just by calling my Python with a different set of functions, I can do all of that for myself. There's let's see. Oh, there we go. So again, that's this -- add CSS right here is how you can get your, whether you add that or not add it, you'll get different looking outputs. And you have to take a screenshot of running this command with both ways, looking at the file in both ways, and uploading those screenshots to Sakai. In terms of grading for this assignment, there is a grading rubric posted just below here. And there are, so there's 11 functions that have failing doc tests. Each one of those functions is worth 1.5 points. So there's a total of 16.5 points just for completing the doc tests. And there are 18 points total in the assignment. The last 1.5 points are for those 2 screenshots and uploading those 2 screenshots. So because the doc tests will display exactly what things are failing and what things are not failing, you'll know exactly what your grade is when you upload it. There's also a bunch of extra credit related to this assignment. So at this point, I have 2 different options, each worth 1.5 points. So currently, you can get up to a 21 out of 18. There's lots of more extra credit ideas that I can add on to this, though. So if anybody's itching for more extra credit than this, let me know, and I'll add some more options. But basically, each of these two options are implementing some additional sort of markdown that you weren't required to do for your original, the standard points. But if you do it, so here, this is how you do a list in Markdown. That would be converted to something like this normally, but if you convert it to something like this instead, then you'll get the extra credit for this, this part of the assignment. Yeah, there's probably still lots of questions about like details of how you go about implementing all of these things, and other questions about the assignment. But at this point, are there any questions just about the how the grading rubric works for the assignment, or what to expect from that? Okay. Then, so the last thing is how you actually get access to all of these files. There's a number of ways to do this on GitHub. So here are these 3 files. You can always just click on a file and then press the raw button right here to download the file, whether it's no matter what kind of file it is. If it's if it's the image file, so it'll say download in this case, and then you can download it same way you download any file. You can also always download everything in the class. If on the course homepage, there's this green code button and then a download zip right here. You could press this and it'll download the entire all the contents of the class, including the homework one right here. And so you could get the files that way as well. So what we'll talk about next is how you actually go about implementing the functions for this assignment. But are there any questions about anything else before that? Okay, so also up on GitHub for today, there's this under the week 4 folder, there's this file Monday section1.py, and that's what we're going to be taking a look at right now. So I'm looking at the Monday section1.py inside of the week 4 folder, and this just has a single function inside of it that has some doc tests. This function is going to process this input string and output a string that's been modified to remove the HTML tags inside of it. So the format or the techniques that we'll use to implement this function are the same sort of techniques that you'd be using to implement all of the functions in the homework 1 assignment to make all those doc tests pass. So the first thing that we'll do is, or the first thing you want to recognize is that this accumulator pattern idea is going to be a good thing to work with throughout this assignment. That here are, again, the function is telling us to remove something from a string. But just like we don't want to remove things from lists because that makes things weird, we also are not going to actually remove things ever from strings. We're just going to create a new string and add on to that string all the things that we don't want to remove from the original string. So in this case, so our input is text. So I'll say our output, call it new text, and start it at the empty string. So when it was a list, I always called it accumulator. Here, I'll call it new text as like this is the version of the old variable, but it's the new one that's had the things removed from it. And what I'm going to do is have a for loop for I in range of length of text like this, and then do something with text at I. So just like when we had a list, I'm going to come down here, say text equals this is a test. Just like when we had a list and we wanted to get a particular element inside of that list, when we have text and we want to get a particular character inside of that text, we can use the indexing operation. So if I do text at 0, that'll get me the T, the very first letter in this. If I do text at 5, that'll get me this I right here. And text at -1 will get me this last T over here. -2, get me the S. So the indexing works exactly the same inside of a string as it does inside of a list. And actually, so strings, just like the range function, are what we call list-like objects. And so I could convert this text into a list by doing list of text like this. And now I get this big list of individual characters where each individual character is in the corresponding position. So you won't need to do this at all in the assignment. It's just good to know that the text behaves in the same way as the range in the list. And so all the things that you can do to ranges and lists, you can do to this text too, essentially. Was there a question?
You're converting with the list function.
So yeah, when I do something like range 3, if I could convert that into a list to see what are the actual elements inside of the range 3, with the text, I can also convert that into a string like this. Let's see, so we'll do something with text of I. For now, we'll just do new text plus equals text of I, and then return new text like this. So here, what I'm doing is I'm just adding in all of the characters one by one onto new text, appending them on, and then at the end, returning what it is. So get out of my interactive Python mode. Let's run the doc test just to see what this looks like. Python 3-m doc test, Monday, section1.py, hit enter. And we can see that everything is failing, because if we look at, say, this last one right here, when we have to delete HTML of this big string right here, well, it's not doing it. It's just, this is what it should happen with the HTML tags deleted, but we're still leaving the HTML tags in place because I'm just adding all of the characters one at a time onto the text here. What we're going to have to do is add some if statements inside of this for loop that will check to see, are we currently looking at an HTML tag? If we are looking at an HTML tag, then let's not add it to the text. If we're not looking at an HTML tag, if we're just looking at normal text, then we can add it up here. And so that's going to be our basic strategy, is to add some if statements right here to control what gets added or not added to our new text. And I think we're close enough to out of time for today that we'll do that next time. Finish up this function, and once we finish up this function, we'll have talked about all of the techniques that you'll need to actually complete the Markdown to HTML compiler. Yeah, if anybody has any questions about any of that, I'd be happy to stick around and answer them. Or if you have questions about lab or the quiz, I have office hours now, so I'll help you with all of that. But otherwise, I will see you all on Wednesday.
I think I forgot to put my name on the second page.
That'll be fine.
Okay, thanks.